Hi everyone, in this video I'm going to solve Cambridge O-Levels Additional Mathematics Paper 2 in a session October-November 2025 Paper 2-3. So let's start with the first question. Question number 1, it is given that p of x is the polynomial. This is the polynomial p of x and it is a cubic polynomial where a and b are constants. X minus 3 is a factor of p of x. When p of x is divided by x plus 2, the remainder is negative 35. Find the values of a and b. Okay, so the two information we have given, the first information is x plus 3 is the factor of p of x. So what does this mean? It means when x minus 3 that is equals to 0, so we can solve it, so x would be equals to 3. So if it is a factor, it means when in the polynomial you put x equals to 3, your remainder should be equals to 0. Okay, now let me solve p of 3 equals to 0. So just substitute x value equals to 3. So we have a, and here we have 3 cube and minus 7 and 3 square and minus b, and the x value is 3 plus 9, that should be equals to 0. So we have to put p of 3 equals to 0, right? So p of 3 means x is replacing with 3 and put this equals to 0. So 3 cube is 27. So 27 a, 3 square is 9, and we know that 9 times 7 is 63. Negative 63 minus 3 times b is 3b plus 9, that is equals to 0. So now a and b are 27 is a coefficient of a, negative 3 is a coefficient of b, and from 63 minus 9. Okay, 9 minus 63, this is negative 54. So negative 54, that is equals to 0, or we can say 27a minus 3b equals to 54. That is my first equation. Okay, now we have to solve the second equation by use this condition that when polynomial is divided by x plus 2, the remainder is negative 35. So what does this mean? It means when you put x plus 2 equals to 0, your x is equals to negative 2. So this means that in polynomial, when you put x equals to negative 2, your remainder is negative 35. For it is factor, it means the remainder is 0. For remainder, your remainder is negative 35. So now let me solve this one. In the polynomial, just replace x value with negative 2. So a, x value is minus 2 whole cube minus 7 minus 2 whole square minus b, we have minus 2, and plus 9, that is equals to negative 35. So minus 2 cube is negative 8a, 2 square is 4, and 4 times 7 is 28. So negative 28, negative times negative is positive 2b, plus 9 equals to 35, negative 35, sorry. Okay, now minus 8a plus 2b, that is equals to negative 35, and shift the 9 on the other side, negative 9, and 28 becomes positive 28. Okay, let me solve on calculator. What is negative 35, negative 9, and positive 28? That is 6 minus 16. Negative 8a plus 2b equals to minus 16. Okay, so in order to simplify the equation, we can simplify both equations by dividing. This equation is divisible by 3 and this equation is divisible by 2. Okay, so 27 is divisible by 3, 3 is divisible by 3, and 54 is divisible by 3. This equation is divisible by negative 2. We can say negative 2 because I want to keep this coefficient positive. I want to take it. Okay, now the resulting answer is 3 times 9 is 27, 9a, 3 times 3 is 9, and 3 times 1 is 3, 4 and 5, 24. 3 times 8 is 24, so it's 18. Now this is your first equation. Let me erase this. This is the resulting first equation. Now for second equation, 2 times 4 is 8, 2 times 1 is 2, and 2 times 8 is 16. That is my second equation. Now you can see we have the two equations. Okay, now b coefficients are negative. Let me subtract the two equations to get the value of a and then b. We can solve these two equations simultaneously basically. Okay, now here we can say subtract equation 1 and equation 2. Okay, so when we are subtracting, write down the equations first. So 9a minus b equals to 18 here, and 4a minus b equals to 8. So whenever we subtract the equations, we have to change the signs. Negative, this change to positive, and this change to negative. Negative b and positive b, this is cancelled out. From 9, if you take away 4, we are left with 5. So we have 5a. And from 18, if we take away 8, we are just left with 10. Okay, now the a value is 10 divided by 5, and 5 times 2 is 10. From here we got the a, which is equals to 2, right? We got the value for a. Now plug this a value into your first equation or second equation and solve for b. Okay, now we can say put a equals to 2 in equation 2. I would like to put in equation 2. You can do in equation 1 as well, because you will get the same answers whether you are substituting into equation 1 or in equation 2. So the equation 2 is 4a minus b equals to 8. So 4a, when you shift the 8 on the other side, minus 8, and shift the minus b on the other side, becomes positive b. So 4a value is 2, minus 8 equals to b. 4 times 2 is 8. 8 minus 8 is your b, and 8 minus 8 is 0. So 0 is your b value. So b is equals to 0. Oh, sorry. B equals to 0. This is my solution for b. Okay, now let me read the question again. Okay, find the values of a and b. We just need to solve for the values of a and b. Okay, so we have done with question 1. Now for question number 2, part A, number 1, the diagram shows the graph of y equals to f of x. So look at this graph. This is y equals to f of x. On the same diagram, sketch the graph of y equals to f inverse of x. It's a 1-mark question. Just sketch the graph of f inverse of x. Okay, so we have f of x. Okay, this is f of x. We need to sketch f inverse of x. So if it has some x-intercept, some point over here, it has some x-intercept, right? Now f of x has some x-intercept close to 0, then it means f inverse of x should have some y-intercept which is close to 0, right? And the shape of the graph is this. Let me correct this. Yeah, this is how f inverse of x look like. Okay, it's increase in x. You can see it is increasing. So the x, there is some x-intercept which is closer to 0. Now for f inverse, there is some y-intercept which is closer to 0, right? And now the x values, it covers the x values and the positive y values, and now it covers the positive y values and as well as the positive x values. So this is how the f inverse, graph of f inverse look like. Okay, so we have done with the first part of A. Now for the second part of A, describe the relation between the graph of f of x and the graph of f inverse of x. It's a 1-mark question. So what is the relation between these two graphs? F of x and f inverse of x. These are basically the reflections of each other along the line y equals to x. So the relation is a reflection along the line y equals to x. Right. Now for part B, A function g is defined by g of x is e to the power root of x minus 2 for x is greater than equals to 2. Number 1, find an expression for g inverse of x. Okay, to get the expression of g inverse of x, first step is to put y equals to g of x. So y equals to e to the power root x minus 2, right? Next step, you have to switch the variables. Y switch with x, e to the power root x switch with y minus 2. Now in the next step, we have to solve for the variable y. That is my g inverse of x. Okay. In order to solve for y, okay, we have to take a natural log on both sides. So natural log of x equals to natural log e to the power root y minus 2. Okay, now we apply the property that anything which is in the power comes before the log. So natural log of x is equals to square root of y minus 2. This thing is multiplying with natural log of e, and we all know that the natural log of e is always equals to 1. So this thing is equals to 1, right? So here we are left with the natural log of x is equals to square root of y minus 2. To solve for y, we have to do the squaring on both sides. Now this square and the square root is cancelled out, and we are left with the natural log of x is equals to y minus 2, sorry, its whole square. Yeah, now for y, what is the y value? Your y is, shift the 2 on the other side, so this is 2 plus natural log of x whole square. This y is my g inverse of x. You got the g inverse of x, right? Now for the second part, write down the range of g inverse of x. So the range of g inverse of x is this. We can say the range of g inverse is basically equals to the domain of g. Domain of g of x. Okay, so what is the domain of g of x? So the domain of g of x is x should be greater than equals to 2. That domain is x is greater than equals to 2. So from here we can easily get the range of g inverse of x. So we can say the range of g inverse is y is greater than equals to 2, because for range we use the variable y, right? For domain we use a variable x. So this is the range of g inverse of x. Now for the third part, a function h is defined by h of x is this function for x should be greater than 0. Find an expression for g h of x in its simplest form. Okay, g h of x. So we have g and h of x, that is equals to g, and what is h of x? H of x is 1 over x square plus 2, and the g of x is e to the power root of x minus 2. So let me write down g of x over here. E to the power root x minus 2. So x and x over. Now g, this whole thing is x. So you have to replace everything over here, right? Okay, so gh of x, this is g of x would be e to the power square root of x. This is your whole x now, and then minus 2. Okay, when we simplify this, plus 2 and minus 2 is cancel out. Root of 1 is 1. Root of square root of x, 1 over x. E to the power 1 over x basically. Gh of x is e to the power root 1 over x square, or simplify e to the power root of 1 divide root of x square, and that is e to the power 1 over x, or e to the power negative x. This is a simplified expression. We need to form the answer in the simplest form. Now for question number 3a, number 1, write down x square minus x minus 6 in the form of x plus a whole square plus b. A and b are constants. Okay, so we have to convert basically the standard form of the quadratic equation into the vertex form. For this, we have to take the x square coefficient common. So x square coefficient is just 1. So take 1 common from the first and the second term. Next, you have to take the coefficient of x, which is -1, and divide it by 2 and take its whole square. So that is 1 by 4. So add 1 by 4 inside the bracket. So every time you have to take the coefficient of x, divide it by 2 and take its square. Whatever the answer, you have to add and subtract that answer inside the bracket. Let me do this. X square minus x plus 1 by 4 minus 1 by 4 and minus 6. Okay, now we have to combine the first three terms. Okay, and the last term is minus 1 by 4 is as it is, and minus 6. So this is x minus 1 by 2 whole square. We have to complete the square. X is a square, so take x. 1 by 4 is a square of 1 by 2, and negative sign decides this. A square minus 2ab plus b square. Okay, now minus 1 by 4 and minus 6. Let me simplify. What is minus 1 divided by 4 and minus 6? That is minus 25 divided by 4. So negative 25 divided by 4. Now you guys can see this is in the form of x plus a whole square plus b. So what is a and b? A is 1, a is minus 1 by 2, and b is minus 25 by 4. Now for the second part, hence write down the coordinates of the stationary points on the curve y equals to x square minus x minus 6. So you have done this curve and it is written in this form. Okay, so we can write this curve y equals to x square minus x minus 6 in the form y equals to x minus 1 by 2 whole square minus 25 divided by 4. So this is the vertex form. So if I can write down the vertex form of the quadratic is vertex form is basically y equals to a into x minus h whole square plus k. So the stationary point is basically the coordinates of h and k. Okay, so if I compare what is x minus, now their a value is just 1, so we have to consider is 1, x minus h and then k. So what are the coordinates of the stationary point? So the coordinates of the stationary point in this case is 1 by 2 and negative 25 divided by 4. So for this you have to remember this vertex form, a into x minus h whole square plus k. So the standard form of a quadratic is y equals to ax square plus bx plus c, right? Okay, a is a basically coefficient of x square, so x square coefficient is 1, so your a value, that is why it is just 1. X minus something, so that is the x coordinate of the stationary point, and whole square and anything add or subtract with the whole function is your y coordinate of the stationary point. So these are the coordinates of the stationary point on the curve. Now for part B, on the axis, draw the graph of the absolute function for -4 to +4. Okay, so first we need to solve this function, the x-intercepts and the y-intercept, because it's not a sketch, it is draw, means the exact graph we need to draw. And the absolute function graph, we know that it must be in the positive y values, right? Okay, the y values must be positive because y equals to absolute of something, absolute of positive, absolute of negative is always positive, right? So first we need to solve for the y intercept. So y intercept is the point where x should be equals to 0. Y intercept is y equals to absolute of x, put x equals to 0. When x is 0, absolute of -6, so that is equals to 6. Okay, this is my y-intercept, 6. Now let me solve the x-intercept by putting the variable y equals to 0. So when y equals to 0, we have x square minus x minus 6 should be equals to 0. We have to factorize this. 2 times 3 is 6 and 2 minus 3 gives you -1. X square plus 2x minus 3x minus 6 equals to 0. Take x common. X plus 2 is left. Take -3 common. X plus 2 is left equals to 0. The two factors are x plus 2 and x minus 3 equals to 0, and the x-intercepts are x is equals to -2 and x is equals to +3, right? -2 and positive 3. So x is negative 2 over here and x is positive 3 over here, right? These are the x-intercepts. This is the y-intercept, okay? And we have to draw this curve, and this curve has also the stationary points. Stationary points are the turning points basically. X coordinate is 1 by 2, which is 0 0.5. So this is 1. 1 by 2 is 1, 2, 3, 4, 5. This is 1 by 2. And the y coordinate is 25 by 4. What is 25 by 4 in decimal? 6.25, because the y is the absolute, so we have to take a positive 6.25. Okay, so 6.25, where is 6 over here? 1, 2, 3, 4, and 5. We have 7. 6.25 is closer to 6. Yes. Okay. Now we need to just solve for them, and it is extending from here, from this side, and it also extend from this side as well, right? Because for absolute function we have to draw this one, and then this sketch. This is how the sketch look like, and you have some turning points. Okay, so let me draw that sketch. Okay, let me. Okay, I drew it in a more accurate way. So these two straight lines are basically for the absolute function. These two are the x-intercept. This is the y-intercept, and we have some turning point. So let's say here we have a turning point. Okay, so this is how we have to draw the graph for this absolute function from negative 4 till positive 4. Okay, negative 4 and the negative 4 and the positive 4. Yes. Now for part C, use your graph to solve the inequality when when this is a function basically y, when y is less than 4. Okay, so if I can draw the straight line y equals to 4, this is the straight line y equals to 4. Not exactly, wait, let me draw the straight line. Okay, this is y equals to 4, and let me extend this line on the other side as well. Okay, so this is a line y equals to 4. We need to figure out when y is less than 4. Y values are less than 4. These are the set of values when y values are less than 4. At what point it is less than 4? This is the point, this is the point. Okay, when the x values are between these two. Okay, so what is this number? 1 0 1 2 3 4 5 6 7 8 9, negative 0 0.9, and here we have 2 1 2 3 4 5 6 7 8 9, negative 2.9. Between negative 2.9 and between negative 0 0.9. Okay, the first one is when x is between 0 0.9 is less than x is less than negative 0 0.9. From minus 2.9 to minus 0 0.9, y is less than 0. And there is another solution. Okay, it cuts at this point and at this point. Okay, what is this point? And this one is 1 1 2 3 4 5 6 7, 1.7. Okay, and the other one is 3 1 2 3 4 5 6, 3.6. Between 1.7 and 3.6. And when x is between 1.7 is less than x is less than 3.6. Okay, maybe my graph is not exact, but this is how you have to calculate the x values, that when this inequality is less than 4. So you have to draw the line y equals to 4, and less than 4 are these values. So when the x is between, so just figure out at what point the line y equals to 4 cuts the curve, right? So those are the set of values at when the inequality is less than 4. Okay, Now for question number 4, part A, integrate the following with respect to x. Number 1, we have to do the integration with respect to x. Integration of e to the power 5x minus 2 dx. Okay, so this integration is e to the power x, integration is e to the power x, multiply 1 over the derivative of this function is 5 plus some constant of integration. So this is basically 1 by 5 e to the power 5x minus 2 plus c, the constant of integration. 5. Okay. Now for the second part, 1 over 4 minus 3x for x is less than 4 by 3. Okay, so whenever we do the integration of 1 over 4 minus 3x dx, 1 over x integration is natural log of x, right? But the derivative must be completed. So the derivative of this function is negative 3. So we have to multiply by negative 3 and divide by negative 3. Okay, 4 minus 3x dx. Now multiply by negative 3 and divide it by negative 3. Divided by negative 3, right? And here we have minus 1 by 3 is as it is. Now the derivative is completed. So natural log of 4 minus 3x plus constant of integration. So this is the integration for that function. Now for part B, show that this integral equals to this. Okay, so let me start from the left hand side and prove the right hand side. Okay, so we have to do the integration of my from pi by 3 till pi by 2 secant square of half x dx. Okay, so here we apply the formula that the integration of secant square x dx is always equals to tan x, right, plus some constant of integration, right? Okay, so here we can say secant square of x is tan x. X is basically 1 by 2x, and 1 over the derivative of 1 over 2x is 1 by 2, and the limits we have to apply is from pi by 3 till pi by 2. Okay, so 1 over 2, which is 2, so 2 tangent of half x. Now let me apply the limits pi by 3 till pi by 2. Pi by 2 is upper limit, pi by 3 is the lower limit. So let me do 2 tangent 1 by 2 multiply pi by 2 minus the lower limit 2 tangent 1 by 2 multiply pi by 3. So here we have 2 tangent of pi by 4 minus 2 tangent of pi by 6. 2 times 3 it's 6. Okay, now we have to solve tangent pi by 4 is always equals to 1 tangent pi by 6. Okay, my calculator is in radians. Okay, thank god. Tangent pi by 4 is 1, and what is tangent pi by 6? Tangent pi by 6 is root 3 over 3. Okay, so 2, this is 1 minus 2, this is square root of 3 divided by 3. Okay, so how do we have to convert it into form? 2 is outside, take 2 common, and we have 1 minus root 3 divided by 3. This is my right hand side. It is proved that this integral is 2 into 1 minus root 3 over 3. Question number 5. 6 different digits are chosen from the 9 digits 1, 2, 3, 4, 5, 6, 7, 8, 9. So from these 9 digits, 6 different digits are chosen. These digits are used to form a 6-digit number. Okay, find how many 6-digit number can be formed in the following cases. Part A, there is no restriction. If there is no restriction, we can make a 6-digit number 1, 2, 3, 4, 5, and 6. So we have 9 options for the first digit. Then we have 8 options for the second digit, 7 options for the third digit, 6 options for the fourth digit, 5 options for the fifth digit, and 4 options for the sixth digit. Okay, now let me figure this out. 9 into 8 into 7 into 6 into 5 into 4. So this is 60,480. 60,480. 6 digit numbers we can make when there is no restrictions. Now for part B, the number is greater than 700,000. If the number is greater than 700,000, it means the first digit can be 7, can be 8, or can be 9. Okay. So 6 digit number 1, 2, 3, 4, 5, 6. So here you have to fix only 3 options we have for the first digit. It can be 7, it can be 8, it can be 9. So we have 3 options for the first digit. If you took 7, so we have 8 options are left for the next digit, and then 7 left, and then we have 6 are left, then 5 are left, and then 4 are left. Let me simplify this. Okay, 3 into 8 into 7 into 6 into 5 into 4. So 20,160. So 20,166 digit numbers can be formed when the number is greater than 70,000. Okay. Now for part C, the number is greater than 750,000. Okay, for a 6 digit number. So 1, 2, 3, 4, 5, and 6 digit number. It should be greater than 750,000. So 7, it means they in the first digit can be 7, can be 8, or can be 9. Second digit can be 5, 6, 7, 8, or 9, and there is no restriction for the rest of the 4 digits. Okay, if 1 and 1, if 7 is taken over here and 5 is taken over here, so how many options are left? 2 digits are already taken out of the 9 digits. Okay, so if you took 7 and you have to take 5, then how many digits are left? So 7 are left. Okay, so 7 digits are left. So 7 options, and then 6 options, and then 5 options, and then we have 4 options. Yes. Okay, if you take 7, 7 is already taken, you cannot put the 7 over here. So how many options we have? 1, 2, 3, 4. We have 4 options over here. Let me erase all these. What I'm trying to say, that the first digit can be 7, can be 8, or can be 9. The second digit can be 5, 6, 7, 8, or 9. If you took 7, then you are not supposed to take 7, because you have to use every digit at least once. Okay, 6 digit number, a 6 digit, 6 different digits are chosen from the 9 digits. So different digits, you have to do 6 different digits, right? Not no repetition basically. Okay, so 1, 2, 3, 4 options we have for the second, for this number, right? For this, if you take 7 at the top. Okay, so let me calculate this. This must be 1 into 4 into 7 into 6 into 5 into 4. We have 3360. So 3,360 options. We can make those 3,600, 3,360 numbers, right? Okay, so when you took 7 at the first number, right? So same is the case if you take 8 as a first number. Okay, we have again 3,360, right? When you take 8 as a first number, so when you take 8 as a first number, there is no 8, 1, 2, 3, and 4 options for the second digit. If you take 9 as a first number, not 9, so 4 options for the third digit, 3360. Yeah, this is start with 7. Here we have start with 8, and when you start with 9. Okay, so we have the start options are done, right? But now here we have two more options here, right? So you can take 5 for the second digit, you can take 6 for the second digit, right? So you can, again you have 3360 when the second digit is 5, and 3360, when you have a second digit, is 6. Okay, I hope the first three cases are clear. When you start with 7, start with 8, or start with 9. Okay, now I'm trying to say that, so we have done with the first digit. Now for the second digit, if you start with 7, so you're not supposed to take 7. Now you have just these four options, right? So we have done with the starting one. The starting one are, I think, clear to every student. But now we have two more cases here, that the second digit may, if you cancel the 7, cancel 8, cancel 9, we have two more options for the second digit. It can be 5, it can be 6, right? Okay, so if you have the second digit 5 or 6 or 7 or 8 or 9, or you can take all the five cases that the second digit can be 5, 6, 7, 8, 9. So you have the same uh, answers you will get, because the second digit you have to take only once, which is, if you, because cancel the, if you take 7, so you're canceling the 7, so take the second digit 5, and then take the second digit 6, take it 4, 8, take it 9. So I hope you're getting me that what I'm trying to say. So basically you have to add 3,360. You have to add it 5 times, 1, 2, 3, 4, and 5, because the second digit has 5 options, right? Okay, so you have to times it by 5, and you will get the total number of six digit numbers we can make. Multiply by 5, which is 16,800. So we can make 16,800 six digit numbers that are greater than 750,000. I hope this makes sense now. Question number 6, the line y equals to 3x plus 4 meets the curve. It's a quadratic curve at 2 points A and B. So this is a quadratic curve, it is a parabola, right? And the opening of the parabola is upward because x square coefficient is positive. There is some line which meet the curve at 2 points A and B. So we need to figure out the point of intersection of the curve and the line. Find the equation of the perpendicular bisector of AB. We have to figure out the equation which is of the perpendicular bisector of the line AB, giving your answer in the form AX plus BY plus C equals to 0, where A, B, and C are integers. Okay. So I hope you understand what we are trying to solve. So first thing, we need to find the points of intersection. Points of intersection of line and curve. Okay, so y equals to this, y equals to this. So plug the value. So 2, compare basically 2x square plus 8x plus 1. This would be equals to 3x plus 4. Now combining every term, shifting every term to the left, 2x plus 8x plus 1 minus 3x minus 4 equals to 0. Okay, and those 2 points of intersections are A and B, right? Okay, so 2x square, the x, these are the x term. From 8 take away 3 is 5x, and from 1 take away negative 4 is negative 3 equals to 0. Okay, now we can figure out, factorize this. 2 times 3 is 6, or we can say 2 plus 3, that is 5. 2 plus 3 is 5, and 6 times 1 is 6. 6 take away 1 is 5. Yeah, 2x square plus 6x minus 3 equals to 0. So we can take 2 and x common. X plus 3 is left. 2 times 3 is 6, minus 1 is common. X plus 3 is left, equals to 0. So the factor is x plus 3, and the other factor is 2x minus 1 equals to 0. Now we have to put both factors separately equals to 0 to solve for x. X plus 3 would be equals to 0. and from here 2x minus 1 is equals to 0. So we got the x value negative 3, and here we got the x value 1 by 2. So corresponding to these two values, we have to solve for the y coordinate as well by plugging the x into this equation. Y equals to 3x plus 4, right? So here we can say put x values in equation of line y equals to 3x plus 4. 3x plus 4. Okay. Now y equals to 3x plus 4, or y equals to 3x plus 4. I plug both values minus 3 and 1 by 2. 3 times 3, 9, plus 4, that is negative 5. And we have 3 by 2 and plus 4. 4 times 2 is 8, 9, 10, 11. 11 over 2. Okay. Now we can say the coordinates of A and B are coordinates of A and B are okay. So the first coordinate is minus 3, 3 minus 5, 1 by 2, 1 over 11. So let's say A is minus 3 and minus 5, and the B coordinate point is 1 by 2 and 11 by 2. These are the points of intersection of the line and the curve which we have done. Now we have to find the line which is perpendicular to this line AB. So for perpendicular, first thing we need to find the midpoint of the line AB and then the gradient of the line AB. So we know that the gradient of the line is 3, right? So no need to figure out, just figure out the midpoint of AB. Okay, so here we can say the midpoint of AB is adding the x components and divide by 2, add up the y components and divide by 2. You will get the midpoint. This is 11 by 2. Okay, now let me solve this. What is negative 3 plus 1 by 2, and then divided by 2, minus 5 by 4, minus 5 by 4, and the other one y component is 11 over 2, subtract 5, and then divided by 2 is 1 by 4. These are the coordinates of the midpoint of the line AB. So for perpendicular bisector of the line AB, we need the midpoint of the line AB and we need the gradient of the line AB. So this is a line AB. Uh, yeah, because this is the line AB. Because this line cuts the curve at 2 points AB. So this is equation of the line AB. So here we can say the gradient of AB, gradient or the slope of line AB is 3. Line AB is y equals to 3x plus 4. This is the line AB. Okay, so if this is a line AB, then its slope is 3. So what is the slope of negative slope or the gradient of line which is perpendicular to AB, which is negative, and the reciprocal of 3 is 1 by 3. Now we can easily figure out the equation of the line AB. Okay, now equation of line perpendicular to AB, that is y minus y naught is equals to m into x minus x naught. This is the m, and x naught and y naught are the midpoints. This is the x naught and this is the y naught. Okay. Now here y minus y naught is 1 by 4 is equals to m is minus 1 by 3 into x minus minus plus x naught is 4 by 5 by 4. Okay, now we have to convert it into this form. Ax plus by plus c, a, b, c should be integers. Okay. So let me convert it into that form. Y minus 1 by 4 is as it is. Let me simplify the right hand side first. Minus 1 by 3 is multiplying with x, and minus 1 by 3 is multiplying with 5 over 4. So here y is equals to minus 1 by 3x minus 5 over 3 times 4 is 12, and shift on the other side becomes plus 1 by 4. Okay. Now y equals to minus 1 over 3x. Let me solve this constant term. 1 by 4, you have to subtract what is 5 over 12 minus 1 by 6. Okay, now we know that 3 times 2 is 6, right? So if you multiply this fraction by 2, you have to make the same denominators. Y equals to minus 2 over 6x minus 1 over 6. 1 by 2 is 1 by 3 equivalent fraction is 2 by 6, right? Now the 6 is same. Now we have y would be equals to minus 2x minus 1 divided by 6. Okay, or shift the 6 on the other side. 6y is equals to minus 2x minus 1, or here we can say shift all the terms over here. 2x becomes positive plus 6y is positive plus 1 is positive equals to 0. Now this is in the form ax plus by plus c equals to 0, where a value is 2, b value is 6, c value is 1, and all the 3, 2, 6, 1 are integers. Question number 7. Solve the equation secant square 3x plus tan 3x equals to 3 minus 3 equals to 0 for x is between 0 degree to 120 degree. Now the angle is 3x, but the domain is for x. Okay, so let me make the domain for 3. So 0, basically multiply all the 3 terms by 3. 0 times 3 is 0, x times 3 is 3x, and 120 times 3 is 360 degree. So means this angle 3x is from 0 to 360 degree. Let me 3 times 120, sorry, 3 times 120 is 360, right? Okay, now here we use the identity that secant square theta is 1 plus tan square theta, right? So let me use this identity. Secant square 3x is 1 plus tangent square of 3x plus tan 3x minus 3 equals to 0. From 1 take away 3 is minus 2. So we can say tan square 3x plus tan 3x minus 2, this is equals to 0. Now this look like a quadratic equation in tan 3x. Okay, so let me factorize this equation. 1 times minus 2 is minus 2. Okay, so the factors of minus 2 are 2 minus 1 makes 1. So tangent square 3x plus 2 tangent 3x minus tangent 3x minus 2 equals to 0. Take tangent of 3x common. Here we have tangent 3x and plus 2. Take negative 1 common, tangent 3x plus 2 equals to 0. Okay, now the factors are tangent of 3x plus 2, and the other factor is tangent of 3x minus 1, that is equals to 0. Okay, let me put both factors separately. Equals to 0, here we can say tangent 3x plus 2 equals to 0, and tangent of 3x minus 1 equals to 0. From here tangent of 3x is negative 2, and from here tangent of 3x is positive 1. Here tangent is negative, here tangent is positive. Okay, so for 3x the domain is from 0 to 360 degree. If I can draw this coordinate, the coordinate diagram, by using the cast rule CAST, it means all positive in the first quadrant, sine is positive in the second quadrant, tangent is positive in the third quadrant, and cos is positive in the fourth quadrant. Here the first one we use the base angle, and in the second we do 180 degree minus the base angle. In third we do 180 degree plus the base angle, and 360 degree minus the base angle. Okay, now tangent is negative in second and fourth quadrant, tangent is positive in first and third quadrant, right? So now let me figure out the base angles, right? Now the base angles or the principal value of the angle, right? So whenever we are dealing with the base angles, keep it in mind that we have to consider it positive, right? Wait, so base angles. Okay, now the 3x is equals to tangent inverse of not negative 2, tangent inverse of positive 2. And here 3x is equals to tangent inverse of 1. Your calculator should be in degrees because in the question the domain is in degrees, right? So let me calculate this. My calculator is in the radian mode. 3 is for the degree. Okay. Now what is tangent? Tangent inverse of 2. 63.443. 3x is 63.43 degree, and here 3x is tangent inverse of 1 is 45 degrees. Tangent inverse of 1, this is 45 degrees. Okay, so we have done with the base angle for both cases. Okay, now this equation tells us that tangent is negative, and this equation tells us that tangent is positive. So we all know that tangent is negative in in second and third quadrant, and it is positive in first and third positive, second and fourth negative. Okay, so here we can write that tangent is negative, negative, this equation tells us the negative in second and fourth quadrant. And on the other hand, tangent is positive, is positive in first and third quadrant, in first and third quadrant. Okay, now here we can say for the second quadrant and for the third quadrant, right? So for the second quadrant, what is operation? 180 minus the base angle, 360 minus the base angle. Okay, this is the base angle, right? So your angle 3x should be equals to 180 minus the base angle, or angle is equals to 360 minus the base angle. Okay, let me do this. Okay, 180 minus 63.43, which is 116.53. 116.7, we can round it to 116.6 because 57 rounded to 6, and 360 take away 63.43 is 296.6. 296.6. Okay, now the next tangent is positive because here the tangent is positive. Tangent is positive in first and third. First is the base angle, 180 plus the base angle. Okay, so your angle is equals to the base angle 45 degree, and here your angle is equals to 180 plus the base angle, which is 45 degree. Okay, all right, 180 plus 45, this would be 225. So as you guys can see, 45, 225, 116, 296, all of them belongs to 0 to 360. When they are talking about 3x, the angles are 3x. All the 3x angles are between. Now here we can write the solution. 3x can be 116. Okay, we can arrange it from lower to higher, it is better. So the lower one is 45 degrees, and then we have 116.6 degrees, and then we have 225 degrees, and then we have 296.6 degrees. So all these values of the angle 3x are in the range from 0 to 360 degree, right? But the question is about for angle x. We have to solve for x, right? So here we have to solve for x. How do we solve for x? We have to divide everything by 3. So x is equals to 45 divided by 3. 45 divided by 3, this is 15. 116.6 divided by 3. 116.6 divided by 3 is 36.9 degrees. 38, sorry, 38.9 degrees, not 36. Double check. 38.8 and 9 rounded to 9. 225 divided by 3 is 75 degrees, and 296.6. 296.6 divides 3. 98.86 or 98.9. 98.9. These are the solutions for x, and they all belongs to 0 is less than equals to x is less than equals to 120 degree. They are between 0 and 120. Yeah, they are between 0 and 120 degree, all these four solutions. Question number 8. In this question, the units are meters. Okay. The diagram shows a circle center at O. There is a circle, the center of a circle is O, and the radius is 2, means OBOA. This is 2. Okay, OB is also 2. The chord AB has a length 2 root 3. AB is a chord and its length is mentioned. The point Q lies on the circle such that AQ equals to BQ. The point Q lies on the circle. A to Q, B to Q, they have the same length. Okay, right. Now the arc APB is a part of a circle center Q. Okay, APB, this is the arc of a circle, is a part of that circle, and the center of that circle is Q, is the center of another circle. Okay, and this its arc is AP and B. Okay, part A, find the exact value of the angle, the exact value, right, of the angle AQB in radians. AQB. AQB, this angle, the exact value of this angle in radians, we have to calculate it. All right. All right, so in order to figure out the exact value of the angle AQB, A, Q, and B in radians, okay. Now this Q is basically lies on the same circle with the center O, right? Because they said the point Q lies on the circle side that AQ equals to BQ, and the Q is another, this APQ is the arc of another circle with the center Q, but this Q also lies on this circle. Okay, so if Q lies on this circle, if O AOB, consider this triangle and figure out this angle. So if I can say, if I can draw this triangle A, sorry, okay, O is over here, A and B. OA and OB, these two are, radius is 2, and here we have 2 root 3. Let me solve for this angle. If you have all the three sides of the triangle, we can get one angle by using law of cosine. So here we can apply law of cosine on triangle OAB. All right. So let me apply the law of cosine. So the front side of this angle is 2 square root of 3 equals to the rest of the two sides. This side square, 2 square plus 2 square minus 2 into 2 into 2, and cos of the angle between these two sides, which is the angle O. Okay, to solve for this angle O, shift everything over here to root 3, its whole square, minus 2 square minus 2 square. I shift this term and divide everything by negative 2 into 2 into 2, and this is your cos of 0, that angle O, cos of angle O. Okay, now if I can calculate this by doing the 2 root 3 its square, sorry, root 3 bracket and its square minus 4 because 2 square is 4 and 4 divides negative 2 into 2 into 2 is negative 8 minus 1 by 2. So this is minus 1 divided by 2, minus 1 by 2, minus 1 by 2. Okay, that is equals to cos of angle O. To solve for angle O, we can say cos inverse of negative 1 by 2. My calculator is in the degree mode. Let me convert it to the radian mode. It's 4. Okay, now let me do cos inverse of answer. This is 2 pi by 3. Okay, so angle O is 2 pi over 3. All right, so let me move up and figure out. This angle we got is 2 pi by 3. So this is the angle at the center of a circle. So angle at the center of a circle is 2 pi by 3. So what would be the angle at the circumference of a circle? Because the point Q lies on the circumference of that circle. It says the point Q lies on the circle, on this circle, right? Okay, the angle on the circumference of a circle is basically half of the angle at the center of a circle. By using the circle theorem, um, angle at the circumference of a circle is half the angle at the center of the circle. Okay, so the angle at the center of a circle is 2 pi by 3. So what would be the angle at the circumference of the circle? Okay, so that angle is basically AQB. Okay, so from here the angle AQB is half of the angle at the center, which is 2 pi by 3. So these two are cancelled out. The angle is just pi by 3 radians. We have to figure out the answer in terms of radians. So this is the angle in radians, the exact value. Now for part B, hence find the area of the shaded region. Give your answer in terms of pi. Okay, so area of the shaded region. So this is the shaded region. This angle we got is 2 pi by 3, and this angle we got is pi by 3. Okay. Now we need to figure out the area of this shaded region. So we have a circle. This is the circle. center is Q, A, B, and Q. They lies on the center, on the circumference of a circle. This point P, this is another circle with the center Q. Okay, so what does this mean? How do we figure this out? The area for the shaded region. All right, so in order to find that shaded area, look at this, the two circles. So first we have a circle with the center O and the point A, B, and Q. They lies on this circle, right? And OA is 2, OB is 2, OQ is 2. The radius is 2, right? Okay, so then we have another circle with the center Q and it has the arc APQ. This is the arc for another circle with the center Q. So we need to find this shaded area. So what I am trying to explain you guys, that first we need to figure out the area of the sector OAB for this whole sector, and then the triangle OAB. From the triangle area, sorry, from this sector, whole sector area, if you subtract the triangle, you will get the area for this segment, the larger segment we can say, right? Same thing, you have to figure out the area of this sector, no, this sector, area of the sector QAPB, this sector, and the area of this triangle. So from the triangle area, if we subtract the sector, from the sector area, subtract this triangle, you will get this area, right? So from the whole area, if you subtract this one, you will get the shaded area, right? Okay, now let me solve this. All right. Okay, so first thing, I would like to figure out the area of the sector OAB. Okay, so if I can draw that sector, okay, so this is a sector O, A, and B. This one I'm using O, A, no, not this one, OAB. Let me highlight it. This one I'm using. Area of this sector I'm working on. Okay, so area of this sector, as we know that this sector, this radius is 2, we got this angle in part A, which is 2 pi by 3. So what is its area? So area of sector OAB in radians is half radius square theta. So that is half, the radius is 2, take it square, the theta is 2 pi over 3. Okay, so this 2 and this 2 is cancelled out. 2 square is 4 pi by 3. So this is 4 pi over 3. Okay, so we got the area for this sector, right? Now the next thing is to figure out the area for this triangle. Okay, for this triangle, what is the area of the triangle OAB? Okay, now let me solve the area about this triangle. Okay, now area of triangle OAB, area of triangle OAB, that is equals to half AB sine C. Okay, half AB are the two sides, which is 2 and 2, and the sine of angle between them, 2 into 2 into sine of 2 pi by 3. All right, now let me calculate this. Okay, 2 pi by 3. So if you can calculate sine angle, this is in radians, 2 pi by 3 and multiply by 4. Okay, this 2 and this 2 is cancelled out. You have to just multiply it by 2. Multiply by 2. This is root 3. So that area is square root of 3. So what we have done with the area of a sector OAB, the blue one, the yellow one, and area of the triangle, this. Now we need to figure out the area for this segment, the larger segment. How can we solve the area of this segment? From the whole sector area, if you subtract this area, you will get the segment area, right? Okay, so here we can say area of larger segment. How can we get the area for this? From the sector area, subtract the triangle area. Sector area, subtract triangle area. And that area is, sector area is 4 pi by 3, triangle area is root 3. So that is 4 pi by 3, subtract square root of 3. Okay, now let me move to the other triangle. Okay, so here you guys can see that we have a b q. Look at this triangle. Now for this triangle, uh, a, B and Q, these three are the circumference. These 3 points are on the circumference of a circle with the center O, right? So with the center O, if the this angle at the circumference is 2 pi by 3, then the angle over here is half of it, pi by 3, pi by 3, pi by 3. If all the three angles are pi by 3, it means this triangle is an equilateral triangle. Okay, if AB is 2 root 3, this should be also 2 root 3, this should be also 2 root 3. Let me explain you one more time that how I come to know that the triangle AB and Q is an equilateral triangle. ABQ is an equilateral triangle because the point A, the point B and the point Q, they all 3 points lies on the circumference of a circle with the center O. If the angle at the center is 2 pi by 3, the angle at the circumference is half of 2 pi by 3, which is pi by 3. So if the circumference angle is pi by 3, here the circumference is also pi by 3, here the circumference angle is also pi by 3. When all the three angles are pi by 3, which is 60 degree, it means that is an equilateral triangle. And for equilateral triangle, all three angles are 60 and all three sides must be equal, right? Now the next thing I'm going to solve is, let me shade with the blue. I would like to figure out the area for this sector QAPB, for this whole sector. Area for this whole sector, I'm figuring out what would be the area for this whole sector. Okay, now let me figure out the area for the sector QAPB. Okay, let me go down. Area of sector QAPB. Again, half radius square theta. What is the radius for that sector? Okay, so the radius of that sector is AQBQ, which is 2 root 3, and the angle is pi by 3. Okay, 2 square root of 3 radius, and the theta is pi by 3. Okay, so this is 1 by 2. 2 square is 4, root 3 is just 3, and pi by 3. So 2 times 1 is 2, 2 times 2 is 4. 2 times 2 is 4, 2 times 3 is 6. This 3 and this 3 is cancel out. This is just 2 pi. That area is 2 pi. Okay, so area of this sector is done. Okay, now let me solve for the area of, okay, let me use the green one or the orange, this green one. I'm doing the area for this triangle QAB, area of the triangle QAB. Okay, now area of triangle ABQ, we know that it is an equilateral triangle, so its area is half. The two sides are 2 root 3 into 2 root 3, and the sine of angle between the side is pi by 3. Okay, now we have to solve what is sine pi by 3. Sine pi by 3 is square root of 3 by 2. Okay, 1 by 2, 2 root 3, 2 root 3, root 3 divided by 2. So this 2 and this 2 is cancelled out, this 2 and this 2 is cancelled out. These two 3's are root 3 square, and then we have a root 3. So here we have 3 root 3. We got this, which is 3 root 3. All right, we got the area for this triangle A, B, and Q. Okay, so from this sector, if you subtract this triangle area, you will get this segment area of smaller segment. From the sector area QAPB, subtract the triangle ABQ, you will get the smaller area of a smaller segment. So here we can say area of smaller segment, that is the sector area is 2 pi, subtract the triangle area is 3 square root of 3. Okay, now we have the area, this area, and we have this total area. So from the larger, I have this total area, this one and this area. This one is shaded in the diagram only, right? So how do we get this one? From the larger segment, subtract the smaller one, you will get the shaded area. So here we can say the shaded area, larger segment, subtract the smaller segment. We will get the shaded area. Larger segment area is 4 pi by 3 minus root 3. 4 pi by 3 minus square root of 3, and subtract this from the 2 pi by 3, 2 pi minus 3 root 3. Okay, the question is find in terms of pi. Okay, now we have 4 pi over 3 minus square root of 3 minus 2 pi plus 3 square root of 3. Okay, so when we simplify this, 3 times, now if you solve 4 pi over 3 minus 2 pi minus root 3 and plus 3 root 3, the pi terms, 3 times 2 is 6, from 4 take away 6 is minus 2 pi by 3, minus 2 pi by 3, and from 3 take away 1 is just 2 square root of 3. So that is the shaded area. I hope this makes sense. Let me explain everything one more time. So if I raise everything here, so now you guys can see the diagram look like. Okay, so in the first step, we need, the question is to figure out the this shaded area, right? So first thing, we have to solve the area for the sector O, A, and B, an area of the triangle OAB. So from this whole sector area, if you take away this triangle area, we got this whole area, the larger segment, which I called, right? Okay, and then you have to figure out the area for the sector QAPB and the triangle area QAB. So from this sector area, subtract the triangle, you will get the area for the smaller segment. From the whole larger segment, if you take away this smaller one, you will get the shaded area, right? I hope this makes sense now. Now question number 9. Two variables x and y are related by the equation in the form y equals to a x power b, where a and b are constants. The following pair of values of x and y are given. There are 4 values for x and y. Part A, on the axis below, use these values to draw the straight line graph of ln y against ln x. So apply the natural log on everything, right? So if you can do natural log of x here and natural log of y over here. Okay, so what is natural log of 0.61? Natural log 0.61 minus 0.49 minus 0.5. Okay, natural log 4.48, natural log 4.48, 1.49, 1.5, 12.18, natural log of 12.18, that is 2.49, 2.5. Okay, 33.1, natural log of 33.1 is 3.5 rounded to. So we have done with natural log of x. Now natural log of y. Okay, so natural log 1.65, the first value, 0.5, 4.47, natural log 4.47, 1.5. Okay, then we have a natural log 7.39, 7.392, that is 2.0. Okay, the last one is natural log 12.17, 2.5. Now we have all the points. We can easily plot the straight line graph when natural log of x is minus 0.5, natural log of y is 0.5. So you can see this is natural log of x and this is natural log of y. Negative 0.5 is over here. 1, 2, 3, 4. Negative 0.5 and the other one is positive 0.5. So 1, 2, 3, 4, 5 over here. So this is the point, the first one. Okay, 1.5, 1.5. X is 1.5. This ln x, then ln y is also 1.5. This point. So go up. This is the second point. Okay, 2.5 and 2. When we have a 2.5 over here, this value is 2. So 2 and 2.5. 1, 2, 3, 4, and 5. 2 and 2.5. Okay, and then we have 3.5 and 2.5. 3.5 is over here and 2.5 is 1, 2, 3, 4, and 5. 2.5, 3, 3.1, 3.2, 3.3, 3.4, and 3.5. This point, right? Okay, so you have to just draw this straight line. Now you can see this is a straight line graph. We just need to plot the straight line graph of ln y against ln x. Now for part B, use your graph to find the values of a and b. Okay, so the equation was y equals to a x to the power b. So we have y equals to a x to the power b. If you can apply natural log on both sides, natural log of y equals to natural log of a into x to the power b. Now for product, we have to do the addition. Natural log of a times b is natural log of a plus natural log of b. A plus natural log x to the power b. Power comes before the log. Natural log of y equals to natural log of a plus b natural log of x. Okay, so here we can say natural log of y equals to b times natural log of x plus natural log of a. So you can compare this equation by the equation y equals to mx plus c. It's a straight line equation, and your this equation is also a straight line equation where b is your gradient or the slope and ln of a, natural log of a, is your y-intercept. Okay, so what is the y-intercept? Y-intercept is this point, which is 1, 2, 3, 4, 5, 6, 7, 0.75. 0.75, yeah, we can say. So here we can say natural log of a is 0.75, and what is the gradient, the slope? Okay, so from the y-intercept, to get the gradient, you have to use the 2 points. Take any 2 points and figure out the gradient, the b value. Okay, so b over here is basically the gradient or the slope, and it has a formula y2 minus y1 over x2 minus x1. So take any 2 points. The first point I would like to take minus 0.5 and plus 0.5, 1.5 and 1.5. So these 2 points, minus 0.5 and sorry, and 0.5, and the other point is 1.5 and 1.5. Okay, now this is x1, y1, x2, y2. So 1.5 minus 0.5, y2 minus y1, x2 minus x1 divides 1.5 minus plus 0.5. Okay, so from 1.5, if you take away 0.5, we are just left with 1. And here in 1.5, when we add 0.5, we have 2. So 1 by 2, the b value is here is 1 by 2, right? Okay, so we got the b value. From here we can say b is 1 by 2. Now next thing is to solve for the a value. Okay, natural log of a. So this is basically the y-intercept, which is 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.75. So natural log of a is the y-intercept. Natural log of a is 0.75, and that is your y-intercept, ln y-intercept. Okay, so from here solve for a. So a would be e to the power 0.75. That is your a. So we got the value of a and the value for b. Okay, and let me solve this value. What is e to the power 0.75? 2.117, or we can say 2.12. 2.12. Okay. Question number 10. In this question, the units are meters and seconds. Okay. A particle moves along a straight line through a point A. Its displacement s from A at time t is given by, this is the displacement. The diagram shows the displacement time graph for the first 30 seconds of the motion. Okay. So it's a displacement time graph for the first 30 seconds of the motion of that particle. Part A, find the value of t when s is maximum. S is basically a displacement. So when the displacement is maximum, when this is the displacement, when the displacement is maximum, at what value of time the displacement is maximum. Okay. So for maximum, we know that we have to, for maximum, we have to do the derivative of displacement with respect to time should be equals to 0, right? So first we need to figure out the derivative of displacement. Displacement is 10t plus 100 divided by root 2 square root of t plus s 100. Let me write down the displacement equation. S equals to 10t plus 100 divides square root of 2t square plus 100. All right, so let me do derivative ds over dt, derivative of displacement with respect to time. Here we apply the quotient rule, right? So the denominator function we need to write 2t square plus 100 square root. Derivative d over dt of the numerator function 10t plus 100 minus the numerator function and the derivative of the denominator function, square root of 2t square plus 100. Everything divided by the denominator function whole square. Okay. Now let me simplify this further. We have ds over dt. This becomes, this function is as it is, root of 2t square plus 100. Okay, so the derivative of 100, 10t, t derivative is 1, so it's just 10, and 100 is a constant, its derivative is 0, so its derivative is just 10, minus this function is as it is. And for this derivative we apply the power rule. So 1 by 2, we know that the square root is has a power basically 1 by 2, right? Okay, so we have to do first the power, then the base function, and we do power minus 1, and the derivative of this base function is 2t square, derivative is 2 times 2, 4t. This is 4t. So 2 is as it is, at t square derivative is 2t, and that 2 multiplying by 2 would be 4t, right? So applying the power rule over here. So everything divides by this square, and the square root is just cancelled out, and we have 2t square plus 100. Let me simplify this derivative. ds over dt, that is 10 times square root of 2t square plus 100 minus 10t plus 100, and we have multiply 1 by 2 into 4t into 2t square plus 100. We know that 1 by 2 minus 1, so it's 2 over here, so 1 minus 2 is minus 1 by 2. Everything divide by 2t square plus 100. Okay, let me do further simplification. Here we can say 2 times 2 is 4. Okay, and we can shift this power to the denominator to make it positive, right? So now the derivative ds over dt, this becomes 10 times square root of 2t square plus 100 minus 2t into 10t plus 100. What I did, 2t multiply by this bracket, and this term shift to the denominator, square root of 2t square plus 100, because this power is minus 1 by 2. When you shift it to the denominator becomes plus 1 by 2, and 1 by 2 power is basically root. This is 2t square plus 100. Okay, let me simplify this further by cross multiplying. So this term is multiplying with this, so 100 root of 2t square plus 100. This whole thing is multiplied by root of 2t square plus 100 and minus 2t into 10t plus 100, and this divides by square root of 2t square plus 100, and everything divided by 2t square plus 100. I simplify the numerator only, the denominator stays the same. Okay, now this thing and this thing is a square, we can take ds over dt. This becomes 100, and we can say the square root of 2t square plus 100, it's twice, so take it square, minus 2 times 10 is 20 with t square, 2 times 100 is 200 minus 200 t, and this whole thing divide by 2t square plus 10 100 and root of 2t square plus 100. So basically I multiplied these two. Okay, so when the bases, you guys can see this base and this base, the bases are same, we can add the powers. If this expression power is 1 and this expression power is 1 by 2, so when the 1 and 1 by 2, when you add that up, this would be 3 by 2, right? So we have to write this 3 by 2. Okay, so ds over dt, this becomes 10. Now this square and the square root is cancelled out. We have 2t square plus 100 minus 20t square minus 200t divides 2t square plus 100 to the power 3 by 2. Okay, so this is ds over dt, right? Now we can say for maximum, what we have to do, we need to put the derivative of displacement with respect to time equals to 0. So this whole expression should be equals to 0 and solve for the time, because they said we need to solve for find the value of time when the displacement is maximum, right? Okay, so we need to solve for t. Let me put the derivative, this whole thing equals to 0. So we can say 10 multiplied by 2, 2 times 10 is 20 t square, 10 times 100 is 1000 minus 20 t square minus 200 t. Okay, everything divides by 2t square plus 100, its whole power is 3 by 2, that is equals to 0. Okay, now this term cross multiplied, this whole expression multiplied by 0 gives you 0. So these two are positive and negative cancel out. So 1000 minus 200 t, this is equals to 0. So 1000 equals to 200 t. Okay, now 1000 divided by 200, this is your t value. So when I simplify, 0 is cancelled with 0, 0 is cancelled with 0, 2 times 1 is 2, 2 times 5 is 10. From here we got t equals to 5. So we can say the value of time is 5 when the displacement is maximum. So look at this graph, the displacement is maximum at t is equals to 5 over here, right? Now for part B, the particle passes through its starting point again at time t equals to capital T. Starting point again. The particle passes through its starting point again. Look at the graph. So what is the starting point? Starting point is this. Starting point is a point at t equals to 0. So this is the displacement time graph for the particle. The particle passes through this starting point again at t equals to t, right? Okay, the question is part 1, find the total distance traveled by the particle during the first t seconds of its motion. So I pasted the picture for the displacement time graph. We know that this is the time where t equals to 0. So what is the displacement? Okay, so we have the displacement with respect to time. Its function is, let me write down the function one more time. The displacement function is 10t plus 100 divides square root of 2t square plus 100. This is a displacement function, right? Okay. So when this is the time, when t equals to 0, what is the displacement? So displacement at t equals to 0. So this is 0 plus 100 divides root of 0 plus 100. So here we have 100 and square root of 100 is 10. 100 divided by 10, 0 is cancelled with 0, so this is 10. So here the displacement is 10, right? Okay, now we need to figure out for the maximum. As we know that the displacement is maximum when the time t is equals to 5. We have done this. When the time t is 5, the displacement is maximum. So what is the displacement at t equals to 5? So displacement of 5 we need to calculate. So 10 into 5 plus 100 whole divides square root of 2 times 5 square plus 100 and the square root. Let me simplify this. Okay, so 10 times 5 and plus 100, everything divides square root of 2 times 5 square and plus 100. This is 5 root 6. So 5 root 6 is in decimal 12.25. This is 5 root 6, or we can say 12.25. So here the displacement value is 12.25, or we can say 5 root 6. Now, distance and the displacement both are two different things, right? So, the distance traveled, we need to figure out the total distance traveled by the particle during the first t seconds of its motion. And the question says the particle passes through its starting point again at t. So, the starting point, what is a starting point? This is a starting point of the particle where the displacement is 10. And from the starting point, the particle goes up. When t is 5, the displacement is 5 root 6. So this distance we need to figure out, right? And then it go back and reach to its starting point where the displacement is 10. I hope you are getting my point, that first we need to figure out from the distance from the starting point till this point. So from starting till the maximum, what is a distance? You need to subtract these two, and then from the maximum it again go back to its starting point. So we need to figure out these two distances, right? Okay. So when the particle move from the starting point till the maximum, the distance traveled is 5 root 6 minus 10. Okay. So distance upward, we can say distance upward is from the starting point till the maximum. So the starting point is 10 and the maximum point is 5 root 6. So what is the total distance traveled? So the total distance traveled is from 5 root 6 subtract 10. So this is the total distance traveled from the starting point till the maximum. And now we need to figure the distance downward, distance backward, we can say. First it starts from the starting point and then it reached the maximum point. Then from the maximum it go back to its starting point, because the question says it passes through starting point again, right? Okay, so again 5 root 6 and 10, 5 root 6 minus 10. So what is the total distance traveled by the particle? So we can say total distance traveled by the particle is basically the sum of these two, 5 root 6 minus 10 and the sum of 5 root 6 minus 10. So basically there is 2 times of 5 root 6 minus 10. Let me simplify this. 2 times of 5 square root of 6 and minus 10. 4.49, you can say 4.495. This is 4.495. This is a total distance traveled by the particle. I hope this makes sense now. First we need to figure out, because the particle start at t equals to 0. When time is 0, the displacement is 10. It reaches the maximum at time equals to 5. At 5 seconds, the maximum displacement is 5 root 6. Now the displacement and distance are two different things. The particle the particle start when the displacement is 10 and it reached the maximum when the displacement is 5 root 6. So the distance traveled is the difference between these two terms, right? And again from maximum it go back to starting point. We need to figure out the distance, and then the total distance traveled, this distance and this distance, we need to sum them up and you will get the total distance traveled by the particle. Now for second part, use algebra to find t. What is the time value? Time equals to capital T. As we know that when it is capital T, that we know that the displacement at 0 is 10 and the displacement at capital T is also 10. Why? Because the particle passes through its starting point again. So what was the starting point before? The starting point before was 0, and now the starting point is t. So the displacement at t is also equals to 10. So use this information and solve for this is the equation for the displacement. Let me write this down. Displacement at time t is 10t plus 100 divide square root of 20t square plus 100. Is it 20t square or 2t square? It's 2t square, sorry. Hold on a second. It's 2t square, right? Okay, so as we all know that the displacement at capital T is also equals to 10, right? So just write down displacement at capital T, 10 capital T plus 100 divides root 2t square plus 100, that is equals to 10. Okay, now we have to solve for t. So we can cross multiply 10t plus 100 equals to 10 is multiplying with the square root of 2t square plus 100. Okay, now we have to do the squaring on both sides, square of this side and square of this side in order to get rid of the square root, right? So we have to open the formula, the square formula over here. So we can say 10t square plus 100 square plus 2 into 10t into 100. So I opened a plus b whole square, a square plus b square plus 2ab. 10, this is 10 square, and here we have root 2t square plus 100, its whole square. All right. Okay, so 10 is a square of 100. So here we can say 100t square. Okay, and 100 square is 110,000 with 4 zeros. Okay, and 2 into 10 into 100 is 2000 t. This is 10, sorry, it's square. 10 square is again 100, and this square and square root is cancel out, 2t square plus 100. Okay, so 100t square plus 10,000, okay, plus 200t equals to, okay, so 2 times 100 is 2 times 100 is 200, 200t square, and 100 times 100 is again 10,000. Okay, so now we can shift everything to the left side. So these two are the same term, we can cancel this out. So 100t square minus 200t square plus 200t, that is equals to 0. Let me solve for t. Okay, so this is minus 100t square plus 200t, that is equals to 0. Let me take t common. We have minus 100t plus 200. Sorry, I did the mistake over here. 2 into 10 into 100 is 1000 basically. This is 2000. Sorry, t is common. Raise this t and this thing equals to 0. So both factors are separately equals to 0. Capital T equals to 0 or minus 100t plus 2000, that is equals to 0, or we can say 2000 is equals to 100t. By shifting this on the other side becomes positive, cancel the zeros, and here 20 is equals to t. So here we can say the capital T is 20 or the capital T is 0. So we have already done t equals to 0, right? At t equals to 0, the particle starts its journey, right? And at t is equals to 20, when the time value is 20, it changes, it reach its starting point again, right? So here the t value is 30 and this is 30 seconds, right? So when t equals to 20 seconds, it reach its starting point again, right? So this is the value for the time which we need to figure out. Question number 11. A circle has equation x square plus y square minus 25 equals to 0. A second circle has the same radius as the first circle. So what is the radius of the first circle? So radius of the first circle is 5. Second circle has a radius 5. So radius of both circle is 5. Because when you write this down as x square plus y square equals to radius square. So this is x square plus y square equals to 25. So you have x square plus y square equals to 5 square. So 5 square is 25 and this 5 is the radius of both circles, right? And the coordinates of its center are both positive. So the coordinates of the center of the second circle, xy coordinates, they are both positive x and we have some positive y. X is positive and the y is also positive. Okay. The two circles intersect at points A and B. The line AB, okay, has a length 6 and is parallel to the line y equals to minus x. Find the equation of second circle. It must be in this form where A, B and C are constants. Okay, so let us visualize this situation first, right? So if I can draw everything over here, the xy axis first. Wait. Okay, a straight line. It passes through the origin. The xy axis, the first circle passes through the origin, right? And its radius is 5. Okay, let's say this is a radius of a circle. It passes through the origin and this radius is 5. From this radius is 5, this is 5, this is 5. Okay, now the next thing is, okay, we have another circle and those two circles, that circle radius is also 5 and they intersect at the points A and B and its center coordinate should be positive. Okay, so let's say this is another circle. Okay, and that circle intersect at the point A and at the point B. Okay, this circle, the two circles meet at the point AB and there is some center of the circle xy and those two coordinates are positive. You can see here the x values are positive, y values are positive. Okay, and the length of the line AB. So AB is basically the chord of the circle. For this circle, AB is a chord. For this circle, AB is a chord. So AB is the common chord of the circle here. You can say AB is common chord of both circles and they have a length of 6 centimeter, right? The length is 6. The length of the chord A to B, this length is 6, right? Okay. Right, so what information we have given? Okay, the length of AB is 6 and is parallel to the line y equals to minus x. So which is a line y equals to minus x? This is the line y equals to minus x. Hold on a second. So this is the line y equals to minus x. So this line and this line, they two are parallel. Wait, let me draw the exact one, the parallel ones. Yeah. Now these, you can see this is the line y equals to minus x. The y values are positive, x values are negative. So this line is parallel to y equals to minus x. It means y equals to minus x. Hold. Y equals to minus x. So what is the slope of this line? So the slope of this line y equals to minus x is minus 1. This line and this line, they are both parallel. So what is the slope of the line AB? So the slope of the chord AB is also equals to minus 1 because they both are parallel to each other, right? Okay, now we know that from the center to the point on the circumference, this length is 5, and for this circle, same, the center to this circumference, this length is also 5. Okay, So the question is to figure out what is the by using this information, we need to figure out what is the center for this circle, because we know the radius of that circle. Okay, so if I join the line between the two circles, if I use different color pencil, yeah, the red one. So let me join the line between the two circles. So this red line join the two centers of the circle. This center is 0 0, this center is some xy. Okay, so the length, sorry, the chord AB, this slope is -1, this slope is also -1, and the line that join the two centers of the circle is perpendicular to this chord, right? If it is perpendicular, so what is the slope of this line? So we know that the slope for this line is +1 because they are perpendicular to each other. So here we can say the slope of line joining the two centers of a circle, centers of a circle, the slope of the line joining the two center of a circle is 1 because it is perpendicular to the chord AB. Okay, so if its slope is 1, so how do we get the slope 1? Some x coordinate is 0 0, and some the slope of the line by we can find the slope of the line by doing y2 minus y1 over x2 minus x1, right? Okay, so use a formula for the slope. Slope has a formula: y2 minus y1 divides x2 minus x1. If the we have some xy and we have some 0 0, right? The slope is 1, one coordinate is y minus 0, the other coordinate is x minus 0, so the slope is 1, that is y over x. How do we get 1? So means the y value is some a, the x value is some a. When you cancel both of them, you will get 1. So it means the x and y, the center, the coordinates of center of the second circle should be a, right? So we got these coordinates are a and a. Okay, green one. Okay, so these coordinates are a and a, means they have the same coordinates and both are positive. Okay, now we use the chord length formula. So what is a chord length formula? Chord length is 6, that is equals to 2 times the radius of a circle plus the square of the radius, right? Let me write down the formula first. Okay, so the chord length L is basically equals to 2 times square root of radius square plus d square. This is a chord length formula. So L is basically the length of the chord of a circle. R is the radius of this circle or the radius of this circle, as we know that both circles have the same radius. And D is the perpendicular distance from the chord. This distance you can measure from the center to the circumference, this distance, or from this point to this point, that distance. Okay, so now let me use the chord length formula. Chord length formula. So with the help of this formula, we can easily solve for the distance which is perpendicular to the chord. Yeah, this distance that is perpendicular to the chord. From the center to the chord, this distance, or from the center to the chord, this distance is d. This is d and this distance is also d. Okay, that is L equals to 2 times square root of radius square plus distance square. Chord length is 6, that is equals to 2 square root radius is 5, we take it square plus d square, the perpendicular distance from the chord to the center. Okay, so 2 times 3 is 6, you have 3 over here, and the square root of 25 plus d square, Now we have to do the squaring on both sides. 3 times 3 is 9, and this is square, and the square root is cancelled out. 25 plus d square, right? Okay, sorry, I wrote it wrong. It's minus radius square minus the perpendicular distance. This is negative, because I was also thinking that something is wrong here. Root of negative number does not exist. Okay, now shift the d square on the other side, becomes positive. From 25, if we take away 9, that is 25 minus 9, sorry, 16. Yeah, so d square is 16, and to solve for d we have to take a square root. You will get plus minus 4, but distance is always positive. That is why we have to consider d is equals to 4. Now we got the d value. So what this d value means, this d value is the perpendicular distance from the center of a circle to the chord of a circle. So this perpendicular distance, we can say this perpendicular distance is now 4, and this perpendicular distance is also 4. So the distance between the two circles is 8. Okay, now we can say the distance between the centers of circle is 8, right? So the distance formula is basically square root of x2 minus x1 whole square plus y2 minus y1 whole square. Okay, now the distance is 8. That is, first coordinates are origin, the second coordinate we got is AA, right? So here we can say a square plus a square. So 8 would be equals to root 2 times of a square, and 8 is equals to a is outside and root 2. So what is a value? From here we got the a, which is 8 divided by square root of 2 is your a value. Or if I can solve 8 divide square root of 2, that is 4 root 2. 4 square root of 2. This is my a value. Okay, so we got the a. Now a is basically the coordinate of the center of the second circle. So what are the coordinates of the center of the second circle? So we can say coordinates of center of second circle are a a. So those coordinates are 4 root 2 and 4 root 2. So all this we did to get the center, the coordinates of the center, because we need to solve for the equation of the circle. For equation of circle we need the radius and the center. We have the radius for that circle, but we don't have the center of the circle. Now we get the center of the circle, right? So it is better to draw the diagram to understand what is happening. So first draw the coordinate axis, then draw a circle with the center origin, and the radius is 5. Draw another circle in the first quadrant where x is positive and y is positive, because it is mentioned that the center of that circle must have the positive, both coordinates must be positive, right? And these two circles intersect at the point A and B, and AB is basically the common chord of the circle, and it has a length 6, and this AB must be parallel to y equals to minus x. If this slope is minus 1, this slope is minus 1, right? And as we know that the length, the line AB and the line joining the two centers of the circle, both are perpendicular to each other. Now we have to use a formula for the chord length is always equals to 2 times radius of a circle minus the perpendicular distance from the center to the chord of the circle. So here we will get the perpendicular the distance 4, this distance is 4. So it means the from the distance between the two centers of the circle circle is 8. Once we get the distance formula, use it and you will get the coordinates of the second circle, the center of the second circle. Now we can write down the equation of circle. Now we can say the equation of second circle is x minus a whole square plus y minus b whole square equals to radius square. A and b, basically these are the a we can say. Okay, don't confuse with this b. These are the coordinates of the center. So x minus 4 square root of 2 whole square plus y minus 4 square root of 2 whole square. Radius is 5 square. Okay, so this is the equation of the second circle, but we need to solve this in this form. Okay, so it is better to open the squares of both a minus b whole square. So this is x square minus 2 into x into 4 root 2 plus 4 root 2 whole square plus y square minus 2 into y into 4 square root of 2 plus 4 square root of 2 whole square. 5 square is 25. So this is x square minus 2 times 4 is 8 x root 2. 4 times 4 is 16, root 2 square is just 2, plus y square minus 2 times 4 is 8, root 2y, and we have plus 4 times 4 is 16 and 2 roots 2 square is just 2, which is 25. Okay, now x square, and this is minus 8 root 2x plus 16 times 2 32 plus y square minus 8 root 2y plus 32 and minus 25 equals to 0. Now let me simplify these constant terms. 32 plus 32 minus 25, that is 39. Okay, so here we have x square plus y square minus 8 root 2x minus 8 root 2y and plus 39, that is equals to 0. So this is the equation of the second circle in the form y equals to x square plus y square plus ax plus by plus c equals to 0. Okay, where a, b, c are constants. Okay, so that was the last question of our paper. If you have any queries, please let me know in the comment section and please subscribe to my channel. Thank you for watching. See you next time. Take care.